So we were looking at the inverse functions, and now I'm going to look at the inverse functions using the calculator. So if we want to see this demonstrated on the calculator, remember we talked about how inverse functions are basically when you switch the domain and range. It's exactly what we saw in this example. All the x's and y's from the original function switched places for the inverse function. So let's look at an example of an inverse function, and we're going to learn to solve and figure these out later on. The cube function, where you actually cube x cubed, x to the third power, is actually inverse to the cube root function. So when you put it to the third power and you cube it, you get the reverse, or the inverse when you take the cube root. You take the third root instead of putting it to the third power. So let's check out the graph. The x cubed, your cube root, your cubic is first, and your cube root will be second. So let's watch them. Oops. As they come up, you see that this is the cube right here. That's the cubic. And this is the cube root going sideways. Everything is going to change places. Remember, the domain and the range switch. So x comma y in the cube function becomes y comma x in the other function. Not because the y coordinate comes first, it's the actual value. So whatever the y coordinate was for the first function in the cube, it becomes the x coordinate for the cube root. So let's look at the table. If you look at the table, I'm going to go all the way up to the top. And let's start off with 1. Simple enough, right? Remember, y1 is your cubic, y2 is your cube root. So for y1, x is your domain, y1 is your range. So when x is 1, domain, y is 1, range. Now, for the second function, x is your domain, y is your range. So when x is 1, y is 1. That's the same all the way across. That really doesn't help us, okay? So let's come down here and let's look at the second one. In the first function, when x is 2, y is 8. Now what that means is in the second function, when x is 8, that y should be 2. So let's come down here. When x is 8, in the second function, y is 2. Do you see how the domain and range have flipped? When x is 8, y is 2 for the second function. For the first function, when x is 2, y is 8. And it's going to work all the way. Let's look at the first function, the original. When x is 3, y is 27. So when I'm looking for the inverse, that means it's going to flip-flop. So it should be now when x is 27, we'll come all the way down to 27, y is equal to 3. Again, you do a flip-flop. So that's all you do for the inverse functions. You flip-flop the domain and range. Now that's an example of when we use cube roots. We can also show square roots, but square root's a little unique because you end up with the square root is the inverse of the quadratic function. But in order for us to actually see, we have to have both cases of the square root function. Now what this means is I have x squared. That's my quadratic. Everybody can see that. That's the parent function for quadratics, right? Okay. So let's look at the domain and range for the quadratics. And I'll go back all the way up to the top so we're not at these crazy numbers. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. Now what does that mean? That means in the inverse, when y is 1, or when x is 1, y should be 1. In the inverse, when x is 4, y should be 2. So what we're going to do is we're just going to look at the positive case right now because there's positive and negative square root. So we'll look at the square root of x. Just like when it was cubed, the inverse was cube root. Now that we have a quadratic, which is squared, the inverse is square root. So now let's see. Okay? Now, if you graph the negative square root function, the negative half, the negative case, it will come underneath and create a complete parabola. And I'll put that on there just so you can see it. Negative square root of x. So now you see the parabola on its side. You can see how the domain and range have switched. So the domain for this one would be in all real numbers, right? Because for the parabola, it goes all the way up, okay? It goes all the way up. The range for this one would be y is greater than or equal to 0, because it starts at 0 and goes up. Now let's flip it over. Now my domain is x is greater than or equal to 0, because it starts at 0 and goes right. And my y would be all real numbers. So you see how my domain and range have switched. So let's look at the table. If I look at the table for this one, remember we talked about how these things should flip, right? In the first function, when x is 1, y is 1. In the second function, when x is 1, y2 is 1. Okay? That's what we're looking for. The domain and the range switch, okay? But that doesn't help us with ones. So let's look at this one. When x is 2, y is 4. That means for the inverse, when x is 4, y should be what? 2. Okay? So let's try another one. When x is 3 in the original function, y is 9. That means for the inverse, when my x-coordinate is 9, my y-coordinate is 3. They flip-flop. So that gives you an example there of how inverse functions work on the graphing calculator and how you can see what the inverses look like on the page.